Hello, and welcome back to the weekly AVIAtest webinar. My name is Jeff. As usual, I'm very happy to welcome you to our little weekly series of webinars concerning aviation, or at least the security of civil aviation. I would like to pass all the greetings tonight to all our watchers. I am very happy to say that all through the private feeds that we distribute on top of the YouTube feed, we see our weekly numbers rising, and it's very kind to participate in our success. Now, also I would like to point out that each week we receive more and more questions. The thing is, I understand that I don't have time to answer everything during the show, but rest assured that if your question doesn't make it to the live show, then you will receive an email a little bit later on during the week with the explanations. All right. So let's start with the topic of this week, which is the last installment of a series about air traffic control, how air traffic control works, and we've covered tower, we've covered flight information service, and today we're going to cover the radar units that are approach and ACC, or Area Control Center. Some of you, notably for our American viewers, may know it as center. Here in Europe and pretty much in the rest of the world, we call it ACC. All right. Before we carry on, if you haven't had the chance, last week we had a delivery of how air traffic control sees you on their screen, which is a little bit complementary to what we're going to do tonight. As basically we're going to review how controllers work using a radar. Last week I talked to you about how a radar works, how aircraft appear on a radar. Well, this week we're going to analyze what controllers do with that information. Okay. First, I would like to talk a little bit more about the different types of units that we have as controllers, or that you will cross as a pilot. And this is a very rough sketch, of course, but we can say that most of the time for controlled flights or for IFR flights, you will encounter a series of ATS units throughout your flight that are basically always in the same order. All right? Let's take a look at different phases of flight. Now here, as you can see, we start at the right of the screen with the ground part of the flight. Okay, here the image says takeoff, but there are things that do happen before takeoff. We know about taxi, we know about clearance delivery for our instrument friends, the lineup, the takeoff, etc., etc., of course. Now, all these things that happen on the ground, the taxi, the clearance part, they are done under the jurisdiction of a tower. All right. It's also called aerodrome control or airport control, how you can see it here, but mostly it's referred to as aerodrome control. And usually aerodrome control is further subdivided. If you remember the webinar about how a tower works, aerodrome control is further subdivided in delivery, ground, and tower. Some airports may combine these different functions in one or two units. It depends, of course, on the quantity of traffic they have to handle. Now, after departure, after takeoff, what happens is that the aircraft will actually be on what we call an initial climb. And that will be done under the control of terminal control. That's more of an American term, or approach control. All right, or we can also use terminal control in Europe or in other parts of the world. Notably, I know that in Asia, many places also were the terminology of terminal control. It's the case of the Far East, for example. But what's really interesting here is that it's a phase of flight that can actually be quite short. I wouldn't say usually, actually. That's why I caught myself saying something that I didn't want to say. It can last for a few minutes, but it can also be very, very short. Because as you may know, or you may understand quite quickly, aircraft especially jet aircraft, that perform much better in higher altitude tend to climb as fast as possible, because the faster they're high, the more economical the flight will be. And we know that for some reason airlines like not to waste money. Okay. And you see how much we pay for a ticket. Let's leave that alone. All right. So departure, initial climb. Basically, what's going to happen is that the aircraft will gain altitude, of course, but also the pilot will maneuver the aircraft to join an airway, or to join a network of airways where they exist, or to join a free routing airspace. We'll come to that in a minute. All right. Now, when we talked about tower and approach, we used this very fancy presentation that I hope I can make work again. Yeah. So here we had our little aerodrome, and let's imagine that you take off. What's happening is that after departure, you will climb into a TMA, controlled by an approach control. And that approach control can be called approach. It can also be called departures, because sometimes if there's enough traffic to justify it, approach control will be further subdivided, like a tower is divided in ground, tower, sometimes delivery. Sometimes an approach control can also be further subdivided, and that would mean in things like departures and arrivals. Sometimes more sectors will take care of arrivals, but we'll talk about that later. And back then I told you that, okay, if you have more airports with more TMAs, above them you usually have airspace that connects everything, that connects all the airport together. And that airspace is controlled by an ACC, Area Control Center. An ACC, as you can see here, is also sometimes subdivided. It's divided in sectors. Now let's take a look at that. Let me show you here a chart of Brussels ACC. That's in Belgium, in Europe. And as you can see here, there are plenty of sectors, of different sectors. You see that they have different shapes, different sizes, and also it may be a little bit difficult to see, but there are also different altitudes. I'll try if I can make that bigger for you. Yeah, it's pretty much the best I can do. All right. So you can see here that, for example, the red sectors have altitudes up to flight level 245 or 185, 245, 205, 205, okay. And then there are the blue sectors on top of these, which go up from 185, or here 185 as well, to up to flight level 245. So you see that it's actually a construction of sectors that are next to each other and above each other, above or below each other, so that basically the whole sky of the FIR is covered by air traffic control. Now, probably you will ask me here, and okay, that's very, very beautiful, but what happens above flight level 245? It's a structure that is very typical to Belgium and the Netherlands and also northern Germany in Europe. It's because it's another unit that takes care of the upper airspace above flight level 245. It's a unit under the jurisdiction of Eurocontrol, the European Agency for the Safety of Aviation, and their Air Traffic Control Center, or their ACC, that controls traffic above flight level 245, is here, as you can see on this chart, on this map here, is located in Maastricht. It's actually, I don't know if you can see my cursor, probably not, but it's a control center that's physically located in the Netherlands, very close to Belgium and to Germany. All right, so this is why we this is how, we sectorize ACCs, and the reason why we sectorize ACCs is because it would simply be too much traffic for one person to handle, of course, because for each of these sectors there's just one controller responsible. Now, sometimes in certain units there will be two of them, but there will always be only one controller talking to the aircraft, actually, and one controller assuming responsibility for what's happening in the sector. A second one may come in to help, to reinforce the team, to do things like coordinations, to talk to the other controllers around, to pass information, etc., etc. But the responsibility for separation will ultimately rest with one person, with one controller. Now, it's quite understandable, actually, if you think about it, because it's the only way that we can make sure that there aren't two people giving instructions to the same aircraft. So that one controller talks to all the aircraft in his sector or in her sector is the best way to make sure that nothing contradictory happens to the aircraft. Okay, now this is about the sectorization of traffic. Okay, so let's go back here to our little presentation. We remember that we also said there can be a part of airspace, a chunk of airspace reserved for military flight. Actually, that's half true. Basically, at least in Belgium, it's probably the case in many countries, but the airspace is primarily military, and the law says that they grant civilian access as they see fit. But okay, this is a detail, of course. There are also airways, as I told you last time, and airways are these corridors, these tubes that connect not only all the TMAs and all the airports, or most of the airports TMAs, but also they connect countries to each other. If you see it from the side, you can see here two different layouts, either with two separate TMAs for two separate airports. Here, one TMA for two airports, because an approach control can also be responsible for a chunk of airspace that serves more than one aerodrome. And then you would see here the airways. Above flight level 195, it's an example, but it's mostly the case in Europe. I think it's also the case in many countries in Asia. Above flight level 195, the official name of an FIR is a UIR for Upper Flight Information Region. Now, this is a collection of airways above London, London being about here in the middle. So you see that there can be quite a lot of airways concentrated in a small area, and okay, it may seem overkill, but it's because each airway has its own characteristics about altitude, about direction. So maybe some airways are just like streets, they can be one way only. Some airways are reserved to traffic heading here or there, or some airways can be prohibited if you fly to a particular airport, saying like, okay, if you want to go to that airport, you cannot use this airway, you have to use that other airway instead. That's a strategical way of handling more traffic, actually. So basically you have now a good sense of how the airspace is structured and how we organize the distribution of air traffic services in that airspace. What I'm going to tell you now, we're going to go a little bit deeper into approach control. Now, as I said earlier, let's go back to the, not to this one, to this flight phases. As you see here, this departure phase of flight is in general handled by approach. What this means is that right after takeoff, or soon after takeoff, when the control tower can no longer see the aircraft through the window, usually that would be a good estimate of when the change happens between tower and approach. Well, the pilot will change frequency and contact a radar unit. When doing that, basically the mission of the air traffic controller handling departures will be to position the aircraft in an airway or towards an airway, either climbing to its cruising altitude or to an intermediate altitude, telling the colleagues further down the line in the next sector, okay, this aircraft is climbing to this altitude or to this flight level because of traffic, because of whatever reason, because maybe we have an agreement. We just agreed between controllers, okay, I'm climbing this aircraft to this level so that you can descend another one above, something like that. There can also be long-standing agreements, standardized agreements that say, okay, you don't need to call your colleague in the next sector if you do this with every single airplane that departs or that goes to that airway, for example. They're referred to as letters of agreement, but I'm not going to go that much into detail. When I learned to be an air traffic controller, I suffered enough over letters of agreement not to bore you with them anymore. All right. Then once the aircraft reaches either the airway or the point at which it's properly positioned to enter the airway system, then the pilot will contact ACC. ACC will still continue providing climbs or descents or vertical movement to the pilot. But mostly ACC is a more horizontal phase of the flight. And if there are ACC controllers in the audience, and I know we have a few watching you regularly, Peter, if you're watching this, I'm happy to say I'm happy to talk about you. What happens in an ACC is that air traffic controllers are focusing on keeping separation between aircraft that are flying along a route. So of course, what's happening along a route is that they will probably be most of the time flying horizontally. Or at least what we can say is that the portion of flight that's going to be horizontal is significantly bigger than the vertical movement. Whilst in a TMA, it's pretty much the contrary. When you see, again, let's take a look at that presentation one more time. Here you have a picture of a TMA, Manchester TMA in the United Kingdom. So let's imagine that we have somebody departing from here and that they want to join an airway that leaves from here. So it means that basically they will be maneuvered in the TMA with regard to the rest of traffic, but they will at the same time be climbing quite a lot. And the most important movement will be vertical, because we try and get the aircraft up as quickly as possible. As I mentioned earlier, it's quite important that aircraft are able to climb as quickly as possible so that they come to a more economical stage of the flight as quickly as possible. Now, ACC is about this. What happens is that, as I showed you in these sectors, every time you pass from one sector to the other, as you see here, there are frequencies, and every time you go into a next sector, beg your pardon, the controller will tell you to contact the next sector, and so forth, until you reach a point where you will start descent and enter a TMA again to approach the destination aerodrome. That would be the approach phase. As you can see, we're here back into terminal control, so again an approach control. And what's interesting here is that, contrarily to departures, the vertical movement is quite slower. It's quite slow, actually. It's significantly slower than for departures, because again, altitude means economical flight, so we try and keep the aircraft as high as possible until the moment that they come in a suitable position to initiate descent. There are people who will tell you about CDA schemes, continuous descent approaches, which is a theory, and I've seen it, I've used it, I put it in practice where I used to work. It's quite efficient. It's a technique, it's an air traffic control technique by which we try and give a continuous descent from the cruising altitude all the way to the ground by relying on the pilot telling us when they are ready for descent, for continuous descent. And then we try, it's not always possible, of course, because sometimes there's traffic, but we try and rethink a little bit the way in which we work to allow for continuous descent. And then after the approach, you would come to the landing stage. Once you get in the proximity or in the vicinity of the aerodrome, then you will be switched over again to tower, where the tower controller will take over. Now, as I used to say when I worked as a controller, we're all controllers, we're all in, how shall I put this? We're not all in the same boat, all right? We're all going to the same place. Our goal is the same, i.e., permitting aircraft to fly safely and efficiently, but we don't use the same equipment, we don't use the same techniques in our work. And I would like to dismiss that received idea that all the controllers are basically interchangeable. There are people who are very good tower controllers who would be terrible ACC controllers. There are very good ACC controllers who would be terrible approach controllers. There are, of course, people who would be good at everything, like everywhere. But it's And I don't want to say that there is anybody better than the other, of course. But what happens is that it's quite a different job, actually, when you think about it. One of my former supervisors once told me, she was very very wise in saying this. She said, actually, approach is basically a conversion job from circular to linear traffic. And I will show you an example that should talk to you. Okay, this is a radar image that I took from where I used to work, and this is actually yeah, I was working this situation. All right. So here you see I had two aircraft flying, and what's happening is that basically, as an approach controller, you receive aircraft from pretty much all directions, from all over the screen. So they come to you in a circular manner. They come from 360 degrees around you. So when you have airplane from all around, well, your job is actually to convert that into a line of aircraft which are behind one another in a suitable position for landing, so basically on an approach. Again, a line of aircraft behind one another. Okay? Whilst the difference with ACC is that ACC is a job where you have aircraft following each other or crossing each other on airways, and you're more a manager of crossings. Basically, you have to let aircraft cross each other, both in the horizontal plane and in the vertical plane. So aircraft that need to climb or descend, because as I was saying, the last part of the climb or the first part of descent will usually happen with an ACC. And what's going on here is that I wouldn't say that one job is more difficult than the other. It's just very different, actually. And one thing that I like to tell my trainees when I gave on-the-job training was that as an approach controller, you would usually try to project yourself 1 minute in the future by the use, and I'm going to see, I don't know, I hope you can see that here, this little predict line. We talked about it last week in our webinar about radars. Using that little predict line, which tells you the position of the aircraft in a certain amount of time that you can select as a controller, you would project yourself 1 minute into the future so that you stay ahead of the situation. That would be a typical value for approach controllers. ACC controllers, if there are any watching tonight, you can also participate in the chat. But I would say that the projection in the future is slightly longer, maybe 2 or 3 minutes, maybe 4 or 5 even. And it's also significant to know that the refresh rate of our screens, of the displays, a few years back when we still had the analog radars, the refresh rate was significantly higher for approach controllers than for ATC controllers, because approach controllers would rely on a much shorter term of information, whilst ACC controllers could afford to look a little bit further in the future, and as such could interpolate much more than approach controllers. But again, This is something that's very different. I mean, every individual working as a controller has their own ways, etc. I don't want to discuss that, and it's perfectly okay. This is just a general guideline, of course. So, now, both ACC and approach controllers work in something that resembles more or less something like this, a controller working position. As you can see, you have a main radar display in the middle. On top you have an information screen that the controller can, where the controller can summon different types of information, etc., etc. Okay, so this is basically how approach and ACC controllers work. Let's go back just a second to our flight phases and summarize everything. Basically, an aircraft departs, climbs with an approach controller, is transferred to an ACC, and then will keep on talking to ACC controllers until they approach their destination, start descent, enter a TMA once again, and are maneuvered around the TMA to reach a point where an approach can be made. Alright, that's about it. Now, I personally was an approach controller, an approach and tower controller, so of course I loved my job, no question about that. But again, because this is another misconception that I would like to tackle here, every control position is different. And when I started working, I used to work in an aerodrome where at first, when I first came, traffic was quite easy. I even say, I don't like too much the term easy because it can go from very easy to completely chaotic in a matter of seconds, but there wasn't too much traffic actually when I started, especially in winter, bad day. We only had training flights, most of them, and maybe 3 or 4 commercial flights per day. And many people would consider it as, yeah, it's okay, it's a job that's not too difficult. And that is true, actually. I don't want people to go and believe that an air traffic controller is somebody sitting behind a screen like you see in the old American movies, in a white shirt and a black tie, with the rolled up sleeves and like boiling coffee on next to the screen and overflowing ashtrays. No, that's not it at all. It's not a very stressful job most of the time. One of my old English instructors, the name was Anthony Hollins, a very, very good gentleman. I don't know if he's still with us because he was quite experienced. But I really had a blast being trained by this gentleman, and he told us one day, you will see when you're qualified that air traffic control is about 90% boredom and 10% panic. Okay, it's a bit of an overstatement. It was not 90% boredom, but what I can tell you about air traffic control is that once you get to the position where you actually work with the aircraft, you know how to do it. You have the tools, you have the knowledge, you have the equipment. It's natural. Now, of course, there are the moments that it turns rather sour, when we have problems, when there are technical issues, when there's an emergency with an aircraft. Of course, it can become quite stressful. But generally speaking, air traffic control is a very, very good job, and you know how to do it once you reach there. So it's not like they're going to sit people in front of a radar who've never been there and say, okay, here's the microphone, and yeah, you're alone to do this now. Another thing that one of my old instructors told me this particular one was Noel Pettigrew, Mr. Noel Pettigrew, also a very fine gentleman who taught me how to be an air traffic controller. It's quite funny. He had a lot of dark humor, I'd say. He was very, very nice. And Noel told us the day we graduated, that our class graduated, Noel told us, okay, guys and girls, you're becoming air traffic controllers little by little, but every single day of your life, of your professional life, that is, at least, you will be nothing more than qualified learners. And this is something that I would like to bring to all of you today. This wisdom of Mr. Noel Pettigrew, former Royal Air Force pilot and controller. Wherever you end up in your aviation career, you are a qualified learner. And believe me, with my 20 plus years of air traffic control experience, that's exactly how I felt from the very first to the very last day of my career. All right. This more or less comes to the end of the topic that I had for today, but as usual, there are the audience questions. All right, welcome back. We're going to take, we've been running 37 minutes already, so again, we're a little bit in a hurry. Never mind. We do have time for one question, and that question will be from Slovakia, and we have a question from František, who's asking, do you think you could shed a light on an airport meteorology service as they cooperate with ATC? When and who decides if an airport operates IFR flights and VFR traffic, etc., etc.? How the meteorological information is passed from the Met Office to the tower, etc., etc. Okay, very good. František, it's very simple. Basically, it's just a matter of organization. What we used at the airport where I used to work was basically computer screens. Meteorological personnel would basically enter the observation that they made into a screen. Actually, would be kind of nice to see again that picture of the controller working position. As you see here, the controller screen that you have on top of the working position can be very easily used by a controller to display meteorological information. So once that is accepted, once you understand how that works, well, basically that's how information is shared. As to your question about decisions, who makes decisions about which flights can operate or not, that would be all the responsibility of air traffic control. So basically it's just a question of coordination between the Met Office and the controllers. So if, for example, let's imagine, and this is something that happens regularly, that we're on a beautiful VFR day and the Met Office says, oops, but in 1 hour I forecast that the weather will become IMC. Well, then the controllers are just informed by the Met personnel. They call the controllers and they say, okay, in 1 hour IMC, and this is going to degrade like this, blah blah blah. It's just a matter of doing a proper briefing between people, and then the controllers can make informed decisions about what to do, about which runway to use, things like that. Now, you also ask in your questions about RVR. That's exactly the same. So there are sensors around the airfield, and the values are actually displayed to the controller. About the status of the runway, about the friction or the braking action of the runway, it's a slightly different thing. There we do have to send personnel on the ground, measure mechanically the values, the braking action, etc., etc., and then a report can be made to the tower, who in turn passes it on to pilots. All right. All the other questions I have received will be addressed in emails because we've already been running for about 40 minutes. So, if there was only one thing I would like you to remember today, is that piece of wisdom of my two instructors. There are many people who, and okay, this is not criticism, of course, but it's a phrase that I've heard many times. Who can't do teaches. Right. It's a huge overstatement, I think. And I'm not saying that because I also sometimes teach, but I've been a controller / OJT instructor at the same time, and I can guarantee you that people who teach are people who know. And these two particular instructors that I had, Noel and Tony actually, were probably in the whole team of instructors that I've met, because there have been plenty of them, and they passed to me wisdom that I can't even begin to imagine getting by myself. So, two things to remember. It's that whatever you do, wherever you end up, you're a qualified learner. Keep an open mind to things like that. And the second one is air traffic control is 90% boredom and 10% panic. It's a little bit of a joke, but I'll leave you with that tonight. Okay. Now, it's been a pleasure doing this once again. Don't hesitate to come back and watch the replays. They should be published. This one will be most probably published tomorrow, maybe still tonight, but it always takes a little while to for the whole thing to complete on YouTube, so it might take a while. Stay safe, stay healthy. I know that it's now a pleasure to go flying again. Still, it doesn't mean that we can do anything without consideration for consequences. Stay safe, stay careful, and fly safe. See you next week, and once again, thank you for watching.